So the rules for class, it's just a reminder. So you have to be on time, and homework is due the night before class. And during class, keep your camera on, don't chat, and ask questions by raising hands or texting in the chat. And use the chat only if you're asking questions or if you need to, if you have an answer for a problem. So I guess I'll start now. So the rate and average speed recap. So distance equals velocity times time, or speed times time. And average speed is total distance over total time, and not the average of those two separate speeds. And work is done directly proportional to the number of workers, while the time is inversely proportional to it. And by directly proportional, I mean that it's like, I think it's the quotient is equal, and for inversely proportional, it's the product is equal. So moving on to homework review. So for this problem, Jeremy can solve a Rubik's Cube in 4 minutes. Michael is very fast and can solve 5 cubes in 12 minutes. And working together, what is the fewest number of minutes it will take for them to solve 10 cubes? So each minute, Jeremy can solve 1 over 4 cubes. And Michael can solve 5 over 12 cubes. And adding them together will give us the rate for when it's like them working together. We'll give it the rate. So 1/4 plus 5/12 equals 2 over 3. So they can solve 2 cubes in 3 minutes together. So for them to solve 10 cubes, they need 15 minutes. Any questions? If no questions, then I will move on to the next problem. So the sum of 4 consecutive even integers is equal to 3 times the smallest number. What is the sum of the 4 integers? So suppose that the smallest even integer is x, and then so the next one will be x plus 2, and then it will be x plus 4, and x plus 6. So adding these together is 4x plus 12, and this equals 3 times the smallest number, which is x. And then if you minus x from both sides, minus 3x, this gives you 0, and this gives you x. So x plus 12 equals 0. So x equals negative 12. Questions? If no questions, then I'll move on. So when Arno drives to work on a highway, he averages 45 miles per hour for the trip. When Arno uses back roads, he can only average 36 miles per hour. The trip on the back roads is 3 miles shorter and takes 5 more minutes than the highway route. How many miles long is the highway route? So we have that suppose that the highway is m miles long. So the back roads would be m minus 3 miles long. And so therefore, we have the time taken on the highway is m over 45, and on the back roads is m minus 3 over 36. So since the back roads take 5 minutes more than the highway route, we get that it m minus 3 over 36 minus m over 45 equals, think it should equal 1 over 12. Okay, so after that, we can solve it so that it would give m minus 15 over 15 equals 1. So therefore, m equals 30. Questions? No questions, then I'll move on. So Chris runs half of the distance to school, averaging 6 miles per hour. And then he jogs the rest of the way to school, averaging 4 miles per hour. The whole trip takes 25 minutes. How many minutes will it take him to run the same way home if he averages 8 miles per hour the whole way? So for this problem, we can draw a graph. So suppose this is his house. This is the halfway point. And this is school. Suppose from home to half is x miles, and from the home to school is 2x miles. So it would take x over 6 hours to go from home to half, and then plus x over 4 to go from half to school. Therefore, and this equals 25 minutes, which is 5 over 12 hours. Solving this equation gives us x equals 1 mile. So the whole way from home to school is 2 miles. And since he's going 8 miles per hour, he takes 2 over 8 hours, which is 1 over 4 hour, which is 15 minutes. Questions? No questions, then I'll move on. So I think I covered this last class. So I won't cover it today. I don't know why it's there though. Okay, so for a system of equations, a system of equation is a set of multiple equations that represent the relationships between multiple variables. So, for example, you may have two equations, a plus b equals 9 and 3a plus 4b equals 32. And there are two simple ways to solve them. It's substitution and elimination. So for substitution is simple. You can just plug in an expression for a variable into an equation. For example, if you have these two, we can substitute 3 for y to get x equals 10. We can also substitute an expression with one variable in terms of the other instead. So we can isolate the variable in an equation. So this, and then if we substitute, we should be able to cancel and solve one of the variables. Afterwards, we substitute the variable back into the equation to find the other variable's value. So I have these two examples, and I'll give you guys a minute to solve it.
Wait, is the second question related to the first?
No, it is not. Okay, so I'll go over this problem now. So what's the value of x and y equals 2x minus 4 when y equals 7? So we can just substitute y equals 7 into the equation. So 7 equals 2x minus 4. So 2x equals 11 if you add 4 to both sides. And then when you divide 2 to both sides, you get x equals 5.5. So that's the answer to the first problem. And solve for x and y. 2x minus y equals 4, y minus x equals 5. So we have that 2x minus y equals 4, and y minus x equals 5. Adding x, suppose this is equation 1 and this is equation 2. Adding x to both sides of equation 2 gives us y equals x plus 5. And then after we substitute this equation, call it equation 3, into equation 1, So we have 2x minus x minus 5 equals 4. So x equals 9. And then after that, we substitute x equals 9 back into the second equation, which gives y equals 14. So x, y equals 9, 14. Questions? Yes, Nolan?
I thought you said it was incorrect.
Huh?
Like, I gave you an answer and you were like incorrect.
Where?
I put 11 over 2.
I didn't see you put 11 over 2. Okay.
I think he was answering mine.
Yeah. I don't think you ever put 11 over 2 in the chat. Okay, then if no questions, then I will move on. Okay, so elimination. This time we try to eliminate a variable from the system by adding or subtracting equations. The basic concept is shown by this example. So I'll give you guys a minute to try and solve this problem. This one. Okay, I'll go over this problem now. So if 2x plus 5y equals -4 and 3x minus 5y equals 19, we're asked to find x. So since when we suppose this is equation 1, this is equation 2. Suppose we add equation 1 and equation 2. This gives us 2x plus 5y plus 3x minus 5y equals 15, because 19 plus -4 equals 15. And then since the plus 5y and the -5y, they cancel, so we can just cancel them. And so this gives us 5x equals 15. So x equals 3. Questions? no questions, then I will just move on. So, solving system with elimination. When solving a system, it's not usually like the previous example when there's like a 5 and a -5 that cancel right away. So sometimes you have to multiply equations by a constant, or sometimes multiply both equations by a constant in order to find one that can cancel. So I'll give you guys a minute to try and solve this problem. This problem right here. Okay, so I will do this problem now. So 3 chocolate bars, C, and 5 lollipops, L, cost $3.70. And 4 chocolate bars and 2 lollipops cost $3.30. How much will it cost to buy one of each? Or how much will it cost to buy one chocolate bar and 1 lollipop? So we are given that 3C plus 5L equals $3.70. And 4C plus 2L equals $3.30. So for this problem, if we multiply the first equation by 4, suppose this is number 1 and this is number 2. If we multiply equation number 1 by 4, this would be 4 times equation number 1, and then we minus this with we minus this with 3 times equation number 2. So this would give us 12C plus 20L minus 12C plus 6L, and this equals 4.90. So since the 12C and the 12C cancel, we just have this, which is 14L equals 4.90. So L equals 0.35. And after substituting L into one of these two, we get that 3C equals $0.65. So C plus L equals $1. Questions? No questions, and I'll move on. So, the geometric representation. And because linear equations can be represented by lines, when you are solving for a linear system of equations, you're just finding the intersection of the two lines. If the equations line are parallel, there will be no solution. If they coincide, meaning if they are like the same, then there are infinite solutions. So I'll give you guys a minute to solve this problem. Okay, I'll solve this problem now. So we're asked to find what system of equations this diagram represents and what's the solution. So for this problem, we see that this is the line and this is another line. So we're asked to find what lines these represent. So we can use slope-intercept form for this one. We have that the slope-intercept form is y equals negative x plus 6, since the y-intercept is 6 and the slope is negative 1. And for this line right here, we have the slope-intercept form is y equals 2x. Since the slope is 2 and the intercept is 0, the y-intercept is 0. So we have that. So therefore we have the system of equations is x plus y equals 6 and y equals 2x. And we are asked to find the solution. The solution is just this point, which is 2 on the x-axis and 4 on the y-axis. So the answer is just that x, y is 2, 4. We can also just substitute it into, we can check our solution by substituting this solution into both, and we can see that it satisfies both. Questions? No questions, and I'll move on. So this is a system of equations practice. So I'll give you guys 2 minutes to solve these 2 problems. Okay, so I'll go over these 2 problems now. So the first one, Kelly and Jason are going out for a run. Kelly leaves 2 minutes before Jason. If Kelly runs at 7 miles per hour and Jason runs at 9 miles per hour, how long will it take for Jason to catch Kelly? So for this problem, so for the first problem, we have that Kelly leaves 2 minutes before Jason and her speed is 7 miles an hour. So she has a head start for 7 over 30 miles. And if Kelly is running at 7 miles per hour and Jason is running at 9 miles per hour, that's the same as if Kelly is standing still and Jason is running at 2 miles per hour. So we're just asked to find how many minutes will it take for Jason to run 7 over 30 miles at 2 miles per hour. So since D equals RT, we have that T equals D over R. So it's just 7 over 30 miles over 2 miles per hour. So the miles cancel, and it takes 7 over 60 miles, which is just 7 minutes. Questions for the first problem? No questions, and I'll go to second problem. So today Pamela is 4 times as old as her brother, Thomas. In 8 years, Pamela will only be twice as old as Thomas. How many years from now will Pamela be 3 times as old as Thomas? So, suppose Pamela's age is P. Suppose Pamela's age is P and Thomas's age is T. So P equals 4T. And in 8 years, Pamela's age will be P plus 8 and Thomas's age will be T plus 8. So it would give us that P plus 8 equals 2T plus 16, which gives us P equals 2T plus 8. And since P equals 4T, we can substitute it into the second equation. So we would have that 4T equals 2T plus 8. And if we minus 2T from both sides, this gives us 2T, and this gives us 0. So we have that 2T equals 8, so T equals 4. And since P equals 4T, then we have P equals 16. And we're asked to find in how many years Pamela will be 3 times as old as Thomas. Using trial and error, we can quickly find that it's in 2 years when Thomas is 6 years old and Pamela is 18 years old. Questions? No questions, and I'll move on. So I have these 2 problems. You guys can try to solve these in 2 minutes. I'll give you guys 2 minutes. Okay, so I'll solve these 2 problems now. So for the first problem, We have Jason takes 20 minutes to travel 1 mile upstream and 7.5 miles when traveling downstream. What is his speed in still water? So, for this problem, we have that suppose Jake's speed in still water is J and the water speed is W. So traveling upstream, Jake's speed would be J minus W. So 1 over J minus W would give us 1 over 3 hours. So J minus W equals 3. And traveling downstream, it gives us his speed is just J plus W. So 1 over J plus W equals 1 over J plus W would just equal 1 over 8 hours. So therefore, J plus W equals 8. So solving these two equations, we add them together to give that us 2J equals 11. So J equals 5.5. Questions for the first problem? And also, just as a reminder, just if you have questions, please raise your hand virtually and not physically, because I may not see your hand. Okay, for the second problem, we have a cycling shop has bicycles and tricycles. Bicycles have 2 wheels and tricycles have 3 wheels. A shop currently has 42 cycles and 90 wheels. How many tricycles does the shop have? So you can solve it using system of equations, but you can also solve it like this. So suppose that it's all bicycles. Then, and since there are 42 cycles, there will be only 84 wheels. But we are told that there are 90 wheels, so there are obviously tricycles. So tricycles have 3 wheels. So if we add a wheel onto a bicycle, it would become a tricycle. And we can add 6 wheels onto these 42 bicycles. So 6 of them will become a tricycle. So 6 is the answer. Questions? No questions, and I'll move on. So I'll give you guys a minute to solve this one. Okay, so I'll go over this problem now. So Bradley scores 34 points in a basketball game by making 12 baskets. If each basket is worth either 2 or 3 points, how many 3-pointers did Bradley make? So for this problem, we suppose that all the baskets were 2-pointers. So this will give us 24 points. But we know that he scored 34 points. So we must have some that are 3-pointers. And if we have 10 points to add, and for each 2-pointer, we can add 1 point to get a 3-pointer. So since there are 10 points to add, so it's just 10 over 1, which is 10 3-pointers. So any questions? No questions, and I'll move on. So I'll give you guys a minute to solve this problem. Okay, so I will solve this problem now. So solve these equations. 3x plus 2y equals z. X plus 2y plus 4z equals 7. And 2x plus 5y minus 2z equals 15. So we have that 3x plus 2y plus z equals 4. X plus 2y plus 4z equals 7. And 2x plus 5y minus 2z equals 15. So solving systems of 3 equations is just that we just want to eliminate one of the variables and also eliminate one of the equations, just like elimination, but with 3 equations. And then after that, we have 2 variables with 2 equations, and we just solve normally. So to solve this, suppose this is equation 1, equation 2, and equation 3. Multiplying equation 1 by 4 times equation 1 minus equation 2 eliminates the variable z, and this gives us that 11x plus 6y equals 9. And then after that, using 2 times equation 3 minus equation 2 gives us, after simplifying, 5x plus 12y equals 37. So after that, we just solve these 2 equations normally. We can solve them by doing 2 times equation, suppose this is equation 4, and this is equation 5. 2 times equation 4 minus equation 5 which gives us that 17x equals negative 19. So x equals negative 19 over 17. And then after substituting x into one of equation 4 or 5, we get that y equals 181 over 51. And substituting x and y into one of equations 1, 2, and 3, we get that z equals 13 over 51. So we have that x, y, z equals negative 19 over 17, 181 over 51, 13 over 51. So that's our answer. Any questions? No questions, and I'll move on. So, solving system of equations with 3 equations and variables. So, this is just what I said earlier with the previous problem. So I will just get you to solve this example. The example right here. I'll give you guys a minute. Okay, so I will solve this problem now. We just asked to solve this system of equations. So the system of equations is just 2x plus y plus z. X plus 2y plus z equals 6 equals 9. And 3x plus 3y minus z equals 24. So suppose this is equation 1, equation 2, and equation 3. We just use equation 1 minus equation 2 gives us x minus y equals 3. And then equation 2 plus equation 3 gives us 4x plus 5y equals 30. So for this problem, we can just use substitution. This gives us x equals y plus 3. So 9y plus 12 equals 30. So y equals 2. And then this gives us x equals 5. And z equals negative 3. So we have that x, y, z equals 5, 2, negative 3. Okay, so I have 2 more problems, and I'll give you guys 2 minutes to try and solve it. Okay, so I'll go over these two problems now. So, in a cage full of bugs, there are beetles with 6 legs and spiders with 8 legs. And there are 162 more legs than bugs and 18 more beetles than spiders. How many spiders are there? So, for this problem, we can just have a system of equations. So, we have that. Suppose there are B beetles and S spiders. And so we have 6B plus 8S equals B plus S plus 162. And we have that B equals S plus 18. So this gives us 5B plus 7S equals 162. And since B equals S plus 18, we can use substitution. So 5S plus 9D, and then plus another 7S equals 162. If we minus 90 on both sides, these two cancel, and this gives us 72. So 12S equals 72. So S equals 6. Questions for the first problem? No questions, and I'll move on. So, for the second problem, today I am 6 years less than half my father's age. In 6 years, I will be 6 years more than 1/3 of my father's age. How old was my father when I was born? Okay, so for the last problem of today, suppose my age is M and my father's age is F. We have that M equals F over 2 plus, minus 6. So F would equal 2M plus 12. And in 6 years, our ages are m plus 6 and f plus 6. So m plus 6 equals f plus 6 over 3 plus 6. These two cancel, and it gives us f equals 3m minus 6. So equating these two equations, we have that 2m plus 12 equals 3m minus 6. So my age right now is 18. So my father's age right now would be 48. And since we were asked to find my father's age when I was born, it would just be 48 minus 18, which is 30. Questions? No questions, then that's it for today. And yeah.
Okay, bye. Thank you.
Bye.
Bye.
Bye. Bye.